All right, the last thing we're going to do for this unit is quadratic formula. This is a formula we can use when we're solving quadratic equations that are not factorable. Like we can't come up with two factors to come up with the trinomial. So we use the quadratic formula. So this is the formula right here. It is x equals the negative b plus or minus the square root of b squared minus 4a over 2a. Okay, and your a cannot equal 0. We can use this when we're asking to find a 0, a root, or a solution. These all mean the same thing. So we can use this formula to get to our answer. So types of solutions that you can possibly have. Let me get my pen here. With the quadratic equation, you can have two real solutions. And these are the steps that you have to implement to use the formula. And this first example, we're going to kind of do that together. So the first thing is we have to make sure the equation's in standard form. Basically, we want the equation equal to 0. And then we need to identify each part. We need to identify the A. The A is your coefficient. It is, I don't know why it keeps doing that. It's your number in front of the x squared. Then you want to identify your b, and then your c is your constant. So we're going to plug these values into the formula. So like on this first one here, the equation is equal to 0. It's in standard form. So I have to think of it like I have ax squared plus bx plus c. And I can make that a little smaller. Oops, not that smaller. So we're just lining up our parts here, and we want the value of each one. So since the a is what's in front of the x squared, well, our a is going to equal 2. Okay. Our b is the coefficient for the x. Well, there's an invisible 1 there, so our b equals 1 here. And our c is our constant, and because we have minus 5, it's going to equal a negative 5. All right, so we're going to plug this into the formula. The formula we're using, and I'm just going to write it over here to the side, is x equals plus or minus our b squared, our b, sorry. Sorry, I wrote that backwards. X equals b plus or minus the square root of b squared minus 4ac. That's all underneath the radical. And then this is over 2a. So what we're going to do is we're just going to substitute the values into this formula. So I'm just going to show the work over here to the side. This would be, I'm plugging in the b, and that is our negative. I forgot to put my negative sign in front of the b. That's a negative sign. So the negative sign, I'm just using parentheses to show substitution. We got plus minus here, and we're going to do our square root. I don't know why it keeps doing that. I need to keep figuring out why this happens. All right, so we're doing 4 parentheses, and we're going to plug in b parentheses square minus the 4 parentheses ac. Okay, and this is all over 2 parentheses. So our b is our 1. Our a, we're substituting the a with 2, and our c with that negative 5. All right, so when we get to here, on our a, we have to put over 2a, so we put a 2 here. So when we get to this point here, what you really need to do is focus on what's underneath the radical, which is all of this. And you want to put that in your calculator. We want to, let me just show you and clear this out. We want to put our parentheses 1, parentheses squared, and then minus 4, parentheses 2, and then negative 5. And hit enter. And this is the value we're going to put underneath the radical. So we're just going to substitute our answer from the computation. So here we would have our negative 1 plus or minus the square root of 41 is 41 is underneath the radical, all over 2 times 2 is 4. So this is what our x equals. This is what gets us to our solution. Now, to get the actual value, the number, we're going to have to do the operation. We're going to have to do the actual math and simplify, put it in the calculator. So because we have a plus minus here, I'm just going to separate it into two possible answers here. One is saying a negative 1 plus the square root of 41 over 4 is 41. And the other one is saying a negative 1 minus the square root of 41 over 4. So we're going to put that in the calculator to get the approximate answer. So we have a negative 1 plus the square root of 41. We enter that, and then we divide it by 4. So one of our answers is approximately 1.35, and then a negative 1 minus the square root of 41, and then divided by 4. So one is approximately 1.35, and then a negative 1.85. So we have two answers here. X equals 1. And it's approximate 1.35, and then negative 1.85. Okay. So basically what we're going to focus on today is making sure you can plug in the formula and to get to your solutions and understanding our types of solutions. So you can have two solutions, a positive, a negative, or two positives, depending on your quadratic, or two negatives. Or you can end up with what we call a one real solution. All right, so one real solution, this is in standard form. We're going to substitute our values for our A. So A should be 1 here, B is equal to negative 6, and C is 9. So we're going to substitute that into the formula. So we're going to have a negative, and then inside the substitution for B, we have plus or minus. Then we're doing the square root of our B squared minus the 4 times A, which is the 1, times C, which is our 9. Hold on just a second. Okay, so we had to finish this up. So it was 2 times 1 here. I forgot to put that at the bottom. And now we are putting this in your calculator. And let's see, I'll give you time to do that. Let's see what this turns into, because I'm going to rewrite it over here to the side. Let me get my pen so we can see what's happening here. So in this first part, because we have a negative outside this parentheses, it's like saying a negative times a negative. So that's going to turn into a positive 6. Okay, we're going to have plus or minus. And hopefully, if we did the calculations right in our calculator here, we should have the square root of 0 all over 2. So really, the square root of 0 is just 0. So this is saying 6 plus or minus 0 over 2. Well, anything added or subtracted to 0 is just itself. It's, your addition identity. So really we have a 6 divided by 2, or 6 over 2, which is x equals 3. So we had only one real solution, where before we had 2. One was positive, one was negative on the previous example. So besides having one real solution, the other type of possibility, we go to the back here, is you can have what we call two imaginary solutions. So what that means is that it's not going to be a real number. It's going to be a complex number. Everything's going to be the same, but what's going to happen is, and I'll show you here, you're going to end up with a real an error that comes on your calculator when you do your computation. So just start off with it's equal to 0, like we normally do. We're going to substitute our values for A, B, and C. So A here is a -1, B should be 2, and C is -2. All right, so now we're going to plug that into the formula. So this would be, the B goes in the parentheses. We have plus or minus the square root of B squared, which would be 2 squared, minus 4 times A, which is -1, times C, -2, all over 2A. So that's 2 times a -1. So when we simplify and do the computation of this underneath the radical, we're going to end up, and I'm going to write it underneath here, is a -2 plus or minus the square root of a -4, all over -2. So what I was getting at is that if you, get my calculator, put the square root of any negative, you get an error saying it's no real answer. It's not a real number. It's what we call an imaginary number. So I tell students to think of it, take the square root like you normally would take the square root, as if it was positive. Okay. But now, oops, sorry. I'm going to do my square root. But now, what we're going to change this solution as an imaginary. Instead of 2 as just a regular number, it's 2i for imaginary numbers. So when I look, whoa, where's my, there it is. When I simplify this, and I'm going to write it over here to the side, I'm going to get -2 plus or minus 2i over 2. Over -2, sorry. All right, so we're simplifying this expression, meaning I'm dividing this -2 to each term. So what that looks like is a -2 over -2 plus the 2i over 2. So that's the positive answer here, or the addition. Let me fix that, sorry. And when I simplify this, this would become -1, oh, actually +1, minus I, or 1i. So that's one solution, one real solution. And then I also have to deal with the subtraction. So this would be -2 over -2, but now minus 2i over -2. Well, negative divided by negative, that's going to give me a positive. And here, negative divided by negative, that's going to give me a plus I. So this is just showing the two imaginary solutions. And if I wanted to keep this with plus or minus, I would just say, or I could just say 1 plus or minus I, just like that. Okay. Now, a shortcut that you could use to help determine if it's going to be imaginary or real is just looking at the part that we have underneath the radical, the part that I highlight and say put in the calculator. So that is called the discriminant. And so the discriminant will determine the equations, the number and types of solutions. When I'm referring to solutions, this right here, that could also mean basically your x-intercepts. It can mean your roots. It could also mean what we call our zeros. So solutions also mean these three things here. So we're going to use this table to help us identify and why the discriminant, excuse me, is so important. So the first thing it says here, step 1, is to put in standard form. Remember, standard form means it has an equal to 0. Let me change my font. So I would say -2 on both sides so that this 2, this constant on the right, would cancel and that would turn into a 0. So then I'm just rewriting the left. So this would be -x squared plus 2x minus 2 equals 0. Then from there, I need to identify basically the A, B, and C. So A here is a -1, B is 2, and C is -2. I don't know why it's doing that. hold on just a second. I wanted to do that. Now, what we're going to do there, I'm trying to figure out why it keeps doing that. Now, what we're going to do is find the discriminant by putting what we have here in the form that says b squared minus 4ac. Okay, let's try that. So when I substitute, this would be 2 parentheses squared minus 4 times my negative 1 times my negative 2. And we want to check to see what this solution is going to be. So this is the part we are putting in the calculator. Okay, we're straight and we're going to put that in the calculator. So I'll go to my calculator, close parentheses, we're squaring that. Then it's minus 4 parentheses negative 1 and then parentheses negative 2. We hit enter and we get negative 4. Okay, that's what we're trying to see, what type of number we get when we do the discriminant, when we plug it into the formula. So this, as we got oops, gotta change my font. Since we got a negative 4 here, which is a negative answer, anytime it's negative, that means there's going to be 2 imaginary solutions. And imaginary solutions, an example of the graph, basically you have your x and your y-axis. And the graph does not touch the x-axis. Okay, so your graph is not going to touch this, so I can open down. Okay, it's going to be a parabola of the U shape. So it can be opening down or it can open up. Okay, but it never touches the x-axis. Okay. Now, if we look at our next example here, to make this into standard form, I'm actually going to have to subtract the 4x and I can line that up with this x. But now the opposite of minus 9 would be plus 9. I'm just going to say plus 9 on this side. These both cancel, and I'm going to rewrite this in standard form. So we start with the highest exponent, that's the x squared, minus 2x and a minus 4x. This makes this minus 6x, then plus 9 equals 0. Okay, and then we still need our parts. We need the a, the b, and c. So our a is 1, our b is negative 6, and our c is 9. We're now going to plug it back into the discriminant, which is that b squared minus 4ac. So in the parentheses for the b is negative 6. I'm going to square that. Minus 4 times a, which is 1. And then my parentheses for my c is 9. We're putting this in the calculator. And we are getting our answer. And we should get 0 here. Anytime we get a 0, this means we have one real solution. Now, a real solution will touch the x-axis, but it will touch it only once. So it's only going to touch it one time. So you have your parabola doing something like that. It could open down. Like I could have it reflect and open down here, but it only touches, I'm just kind of showing, it only touches it one time on the x-axis. All right, and then here, gotta still put it in standard form. So this right here is not in standard form. So to do that, we're gonna have to minus, the 2x and minus 5. And just put it in standard form would be 2x squared plus x minus 5 equals 0. All right, and then we need our A, B, C. So A is 2, B is 1, c is negative I. Now we're putting it into the formula. I'm just going to go ahead and write that. The b squared minus 4ac. So that's 1 parentheses squared minus 4 times 2. So that's in parentheses. And then parentheses negative 5 times that negative 5. This comes out to be 41. And this is positive. So whenever we get a positive number with our discriminant, you're going to have two real solutions. And that means it's going to touch the x-axis twice. So let's say I have a parabola, and it's something like that. So here, that's our two solutions. Or you can say they're the roots. Okay. Or that's also called the x-intercept. Okay. So what I wanted you to do is to practice using this quadratic formula. And so you're gonna do that here on this next sheet. Let me just get my pointer. So what you need to do is make sure that our equation is in standard form, which the first one is, okay? And then what you would want to do is, and you could probably maybe put it over here to the side, sorry, is identify your A, your B, and your C. And then you can put it into the formula, which is negative, sorry, I need to write this better. Negative B plus or minus the square root of B squared minus the 4AC all over 2A. Okay. So on this first one here, hopefully we see our A is 1, B is 4, and C is 2. And now we're just plugging it in and trying to get the answer. So I want you to see if you can do the computation. Just basically apply the quadratic formula and get your solutions. So I just want you to try this. And when you get to number 4, that's when it's not equal to 0. So you do have to put it in standard form. And then on the next page, then we're going to get into the formula, but also the discriminant, okay, which is the last part of our notes here. So whenever we're solving a quadratic function, it means we're trying to find our solution, or we can say we're trying to find our zeros, our x-intercepts. These all mean the same thing. Or we're trying to find the roots. Okay. So if it's y equals, then it is in standard form. Okay, we just kind of substitute the y with our 0 and then go at it. So here they want you to find the solution. And we want you to see, can you solve it using either factoring? Okay, so because this is like saying, I'm going to rewrite it, 0 equals x squared minus x minus 6. This goes back to that the yellow graphic organizer. It's like we have 3 terms here, and anytime I have 3 terms, I'm using my x puzzle. And then I want to see, do I need to slide and multiply or just go straight to factors? So like this one, you're going to go straight to factors. Okay, and it does work out. It is factorable. Here, hopefully on the next one, we see it's a difference of squares. And then we're going to see if it's factorable on the third one. Hint, hint, you're going to have to use quadratic formula. All right, so I just want you to try this, and this is what you're going to turn in. All right, thanks.